Good evening, everyone. Welcome to all of you in the room and those of you watching from your own living rooms at home. I'm Danielle Hicks, Chief Patient Officer here at Go-To for Lung Cancer. This evening, we are going to be focusing on EGFR positive lung cancer. There's been a lot of swirl in the last couple of years about targeted therapies, which really have been sort of in the picture for the last 10, 12 years, something like that. And EGFR was the mutation to first have a targetable drug approved to treat it. So it's really the grandfather, if you will, of lung cancer mutations. And we know there are several others that also now have drugs that are targeted to attack the driver mutation of lung cancer. But tonight we're going to be talking about EGFR. Not only was it leading the way back in 2003 or 4, but it's really leading the way now in how we look at treating early stage lung cancer. And I'm certain that all the fellow mutations will follow. So tonight we have a guest who is very near and dear to my heart and to Bonnie's heart and to Go-To's heart, really, Dr. Shane Dormady. He's an MD, PhD, medical oncologist working at El Camino Health just down the street in, is it Mountain View or Los Altos?
That's
Gatos?
Mountain View and Los
Gatos.
Gatos.
Los Gatos,
sites.
two locations now. So some of you may remember, if you've been around long enough, when my mom was diagnosed, her medical oncologist unfortunately was diagnosed with lung cancer towards the end of her treatment, and Dr. Dormady was working up here and took over for Dr. Fred Marcus for a little while. So Shane is no stranger to Bonnie and her story, and we just couldn't be more pleased to have him with us tonight. We've had a long-standing working relationship with Shane. We've referred patients there. He's referred patients back to us. It really is an excellent example of how foundations like ours can work with healthcare providers like Dr. Dormady. So before we jump in, and this is a repeat for some of you veterans who have been here for a long time, but before we jump into talking about EGFR specifically, I always like to start with a conversation around biomarker testing. We can't stress enough the importance of it, particularly comprehensive testing. Can you talk a little bit about what that is and when someone should be tested?
Oh, sure. I think, again, as Danielle alluded to, she knows more about this than most of the senior researchers on the topic, but I think that the EGFR mutation sort of heralded a new era in oncology treatment in general. We started to think not about treating cancer based on the anatomic location in the body that it came from, but actually getting into the DNA and gene sequencing of the different cancers in the body to figure out, well, you know, on a molecular level, how can we unravel the cancer and target it? And so over the years, you know, not just in lung cancer, but in multiple kinds of malignancies, we've started to find that there are really targeted therapies that can sort of, rather than the carpet bombing approach that chemotherapy is, can sort of home in on the cancer itself like a guided missile. You know, breast cancer is another great example where the number of mutations is evolving, you know, almost monthly. And these are molecular targets for some of our newer medicines. And what you tend to find is with this more focused attack, you often have fewer side effects. You know, less toxicity, more durable responses, and patients with lung cancer whose prognosis was pretty dismal, even as recently as 15 years ago, are, you know, people who were given 3 months to live are now living 3 years, and people who were given 3 years to live are now living decades. And so it's really, it's amazing to watch the pages turn as we really get into the DNA sequencing of tumor cells.
Yeah, I couldn't agree more. I think, you know, these driver mutations, being able to sort of uncover the bad actors that they are as being sort of the reason behind the cancer's growth and spread, and then to have these drugs available to uncover these bad actors and attack them from within really is the sort of the center of this personalized medicine approach, which really, I think, began with the advent of discovering and understanding these biomarkers, EGFR being one.
Yeah, absolutely. And, as with everything, the story evolves where, initially we're so excited to find these molecular targets and see, wow, this is, and not only is there often less toxicity and more durable responsiveness, it's a faster response too for many patients, where patients who are really ill, and if they have an EGFR mutation, for example, you start the medication and literally within days, you can see them healing and recovering and breathing more easily and starting to get stronger and eat more. It's really something. But the complexities that evolve when you start to see that, okay, here's the EGFR mutation, but then within it, there are 20 variants. And within that, there are actually bad EGFR mutations. And so the story evolves further and further, and then you target things for like you're saying, lung cancer in general is a bad actor. You find the EGFR mutation, you have a weapon. But then within the EGFR mutations, there are bad actors, and you find new weapons. And that's kind of what we're going to talk about tonight.
Yeah, it's really exciting to me coming off of World Lung even back in September and ASCO prior to that. Back when I first started attending these meetings, nobody had anything really going on in lung cancer other than maybe chemotherapies that were extending life by 6 weeks.
Yeah.
Right? And now you're really hard pressed to find anyone who's not working in lung cancer to some degree, and not even just big pharma, but some of the smaller biotechs and the like that are really stepping up and putting their best foot forward in order to help identify drugs to target some of this stuff. So,
yeah, one other thought is just that what you start to see too, again, as we evolve from treating the anatomic region of the body, when you start to do the sequencing of the tumor cells, a great example in lung cancer was starting to see overlap with HER2 mutations that were, like one of the backbones of breast cancer treatment, and you start to see overlap there. And then you start to see BRAF mutations that are most commonly seen in melanoma cells. And you're thinking, oh my gosh, there's a common thread here. And the medicines you use for melanoma actually will work on a lung cancer patient. So
yeah, and we wouldn't know that, right, without this comprehensive type
exactly
of testing. So in large part in this country, people are being appropriately tested. But also in a too large part, from my perspective, people are not being appropriately tested.
I actually, I was just at a little symposium on lung cancer. It was actually, they pulled up some statistics that as you drift out to more rural areas, it's actually shocking how many people aren't being tested for these mutations, and frightening.
Yeah, I agree. It is frightening, but it's a reality, right? And I know at GoTo, and I think a lot of you guys know, one of our goals is to increase the rates of this biomarker testing, particularly in the more rural areas, and in educating people through programming like this to become empowered and go back and have these conversations with their providers.
Exactly. These forums are, invaluable to try to spread the word and say, this is the new way to treat cancer. What I always tell patients, because of course, and we're not in a rural area, obviously, but patients still, many of them, even really sophisticated patients. I took care of a dentist once, and he said, I'm highly educated, smart guy, but, the second they told me I had cancer, it was just all emotion.
Yeah.
And it's just every intellectual, kind of logical way to reason through this went out the window. And so you have to tell patients, one of my favorite things to tell them is that, hey, in this day and age, I don't want you to think about this like stage 4, X or Y. I want you to think of this like you have a medical problem, like hypertension or diabetes. And just like those medical problems, if we find the right medications for you based on the sequencing of your personal tumor cells, then we'll keep this controlled long term, just like high blood pressure and diabetes. And I think when patients grasp that message, it's like, wait a minute, okay, the ceiling's not caving in completely. I have a lot of options here. I can start making plans for the future, and we're talking about longer term survival.
Yeah, couldn't agree more. So we know that this testing is important at diagnosis, so we can, as you just said, identify any specific person's cancer on a personal molecular level, and also at progression.
Yeah, it's interesting that, and this is also becoming a really popular topic in the field of breast cancer as well, where you will see certain mutations evolve over time. I'm not sure in lung cancer that I could tell you one mutation that you see evolve quite like that, but things change. It's like the therapies that you expose the cancer cells to induce genetic changes within the DNA of the cells, and all of a sudden new mutations arise, and potentially they can be targetable. So, like Danielle just said, when the cancer looks like it's not responding anymore to a therapy you've initiated, that's always a good time to resend molecular profiling and see if something new has evolved, something that you can target. What's interesting too is just the field of molecular testing has evolved so much too, whereas in the beginning you would have to take a piece of solid tissue and send it away, and then if you were lucky, 3 or 4 weeks later the results would come in, and they're very accurate. But if you have someone who's very ill and you need to start therapy, 4 weeks can be an eternity. So now we have various companies sending liquid biopsies where you can actually analyze circulating tumor cell DNA in the bloodstream for these same mutations, and those tests can come back within 5 to 7 days. That makes it easy to retest at progression. You say, just a tube of blood, let's check again, and you get it back. Oh, okay.
Yeah, so a couple of points. One, liquid biopsies are such an important part of all of this for the reasons that you just said. And I'm curious, at least last time I checked, so I could be wrong on this, but tissue was still sort of gold standard. So if nothing was found in the blood, that doesn't necessarily mean that nothing's there. If something's found, then we know it's there, right? But if you don't see anything, are we still waiting for the tissue to come back?
Absolutely.
Yeah. Okay.
So I think most of us who really embrace the molecular profiling will send a liquid biopsy and a solid tissue biopsy, assuming that you have a solid tissue biopsy that's of adequate quantity and quality to get the answer. You don't want to hold therapy, let's say, to get the perfect specimen, and you can always get a solid biopsy later in the game if you have to. But generally speaking, yes, you should send both, and tissue is still the gold standard, because although I have seen liquid biopsies very rarely catch something that a solid molecular profiling assay missed, it's more the reverse, where the solid analysis on the solid tumor catches something the liquid misses.
Yeah. I think you said something that's important. Well, two things. So one, we don't live in a rural area. We sort of live in a bubble for a lot of reasons, but from a healthcare perspective, for sure, where we have access to quality care in our backyards, like no matter which way you kind of spin, right? And I love hearing you say that you do them in tandem, both the tissue and the liquid, when you can, because I know that that's not always the case. But from just a sheer logic perspective, it makes so much sense to me. Like, if you can do them both at the same time and get a result back within 5 days versus the 3 to 4 weeks, why wouldn't you? And I know that's a whole rabbit hole we don't necessarily need to go down from a payer perspective and cost and reimbursement and all of that kind of stuff. But it feels to me, from a moral and ethical standpoint, if you have access to this type of diagnostics, it should be being done on everyone.
It is, and I think, as with everything, there isn't just one assay or one company doing these things, and they compete for, who has the best assay, and through that competition, I think it's good. Like anything else, when you have competition, you are driving evolutions to the technology and the assay, and speaking to accessibility and payer mix. I mean, my experience is that that competition also breeds great flexibility. When, a doctor like myself who's busy can send a lot of these tests, and then when I have a patient who maybe doesn't have the perfect insurance, I can just say, well, remember all those tests I sent? Maybe we can work something out on this test. And, I think to their credit, the profiling companies, they're pretty flexible. They want to do what's best for the patient, generally speaking, and they'll help out. So I think accessibility and insurance coverage, those things are actually quite favorable.
Yeah, and I think it's a healthcare provider understanding of how to navigate all of that too, right? And having a team to help you to navigate that, right?
Absolutely.
Which not all docs also have the benefit of. So you made a comment that I want to kind of put a pin in, and then we'll jump into some of the exciting stuff happening when we're looking at treating EGFR. But you talked about progression and changes that can happen due to treatment, right? And EGFR, I think, is another good example of that when thinking about T790M, right? It's because of this retesting that was done at progression that all of a sudden people were going, hold on, here's what we're finding. That was originally thought to be strictly a resistance mutation. Like, this mutation came to be because the OG EGFR mutation got kind of smart and figured out a way around, right? And T790M was sort of responsible for that. That's a lot of the research that's happening now, not the only research, but looking at this resistance. But one of the things we found, and you guys heard me like to go to an Alchemy's horn before about this, but T790M through an inherit study that we did through Alchemy and Dana-Farber with GoTo as the advocacy sort of arm of that, was identify T790M as a what's known as a germline or potentially inherited or genetic mutation. And we're doing further studies now, again, hard push, but anybody who's interested in looking into genetic risk factors, we're running sort of Inherit 2.0 right now. But T790M was really the center of what has sparked a lot of this thought process around resistance mutations. That was a long way around me saying what I said just at the very end, but I think it's important. So one of the things that we know is this type of comprehensive biomarker testing, well, not so comprehensive in the beginning, but now really started in later stage patients. We weren't looking at this type of testing in earlier stage patients, but now we are. So can you talk a little bit about how that sort of came to be and why it's important that we're testing patients who are diagnosed early and surgical candidates?
Oh, absolutely. Well, when you're dealing with any type of malignancy, it's always better in the beginning to start collecting all the weapons that you'll have in your arsenal to try to get the best response possible to defeat the cancer. So, as Danielle said, initially it was like, oh, well, these patients don't have a lot to lose. Let's go ahead and try the targeted therapy. But then seeing how well it worked, and in many cases how much more tolerable it was, and it started to be, started to get studied closer to the front line of treatment. If we jump in earlier, if a treatment's working that well in someone who's been treated with 5 different chemotherapy regimens and the cancer is kind of very ugly and resistant to treatment, what happens if we strike first with something like that in the presence of the right driver mutation? And so, the concept being, well, even if it hasn't metastasized, the overwhelming majority of lung cancer patients have, if you incorporated stage 4 and stage 3, that's probably 95% of the patients that you see diagnosed with lung cancer. But if you sort of do a subset analysis on the stage 3 patients, what can we do to enhance their outcome? What can we do to shrink tumor bulk and cytoreduce the tumor so that things like surgery or radiation, or surgery and radiation, have a greater chance of success. And so that's why it's important to know right off the bat, not only what the EGFR status is or any other type of mutational status, but another, breakthrough area of treatment for lung cancer is, of course, immunotherapy. And, data has already accrued that giving even patients with stage 1 lung cancer who have some high-risk features to the tumor, whether that be a really fast growth rate, an aggressive growth rate of the tumor, or something called lymphovascular invasion, where tumor cells are creeping into lymph channels and blood vessels, whether or not the tumor itself was touching the lining of the lung, which is called the pleura, all things that are sort of risk factors for metastasis or a bad outcome. If you have a tumor cell that's heavily expressing PD-L1, which is the target for immunotherapy, there's data now that giving a patient after they've had surgery 4 rounds of chemotherapy with immunotherapy and then extending the course of immunotherapy alone for a full year improves cure rates.
Yeah.
And so that's commonly done now as long as the patient is healthy enough to tolerate that.
Yeah, targeted therapies and immunotherapies have been hot topics for a bit now, right? And now we're looking at patients, and you touched on this a little bit ago, where if you were an earlier stage and you were a surgical candidate, for some people, and this was before, for some people, there were options for what's called neoadjuvant, so therapy before the surgery, or adjuvant therapy after the surgery. And historically, it was some combination chemo, radiation, right, whatever. And now, with targeted therapies and immunotherapies, both approved and in research, we're looking at, are outcomes better? Is recurrence less likely if you're having this either before or after surgery type treatment?
Yeah, especially in the area of stage 3 disease. I think there's now solid data that using EGFR blockers, neoadjuvantly and adjuvantly, immunotherapy, not in the same patient, but neoadjuvant immunotherapy and adjuvant immunotherapy, especially in stage 3, that's rapidly become the standard of care in those situations because it was clear that it was improving outcomes and cure rates and overall survival.
Yeah, agreed. Well, let's jump into later stage disease. So one of the things we get questions on our helpline about, and sometimes in this room and on the street, there are multiple drugs approved for EGFR positive lung cancer patients. How do you determine which therapy is best? And now I'm talking in the stage 3, stage 4 non-surgical patients. Mm-hmm. How do you determine which is the best therapy for that person?
It's getting more complicated, as we said. I mean, whereas before we had the EGFR mutation, then we had ALK and ROS, and now you can actually see a table with, RET mutations, MET mutations, BRAF mutations, KRAS mutations. It's becoming hard to understand how to sequence the treatments. And believe me, I don't have, and no one does. There's not a black and white answer to that question. However, trying to kind of pool data, there was a big clinical trial published called FLORA, which kind of showed that of all of the TKIs, the pills, the tyrosine kinase inhibitors on the market for the EGFR drugs, that osimertinib or Tagrisso was superior to the others in terms of outcome, progression-free survival, overall survival. It also had has an uncanny penetration rate into the central nervous system. And with lung cancer, there's a predilection, unfortunately, for lung cancer cells to metastasize to the brain. So to see a drug that has striking activity in the central nervous system was really a breakthrough. So yeah, Flora kind of said, well, all comers considered, Tagrisso is superior. So that started to give you some guidance, at least with what medication to start with for patients with metastatic disease. But things then evolve, and it's interesting with a predecessor of Tagrisso. They're called Tarceva or erlotinib. There was some initial data that the combination of erlotinib with chemotherapy actually led to poorer outcomes, which I never really understood, and I don't think it was a super large study or had enough statistical power to really flesh out what was going on there. But then Flora 2 was published, where they looked at, okay, we said Tagrisso's the best. Well, how about chemotherapy plus Tagrisso versus Tagrisso alone? And now, as you start to design these trials, obviously when you start going back to, we're saying, well, let's not just fire guided missiles, let's carpet bomb too. So you have to be careful. Patients have to have the performance status and the strength to tolerate that type of attack. But generally speaking, the chemotherapy that we use for, let's say, adenocarcinoma of the lung, usually a platinum, carboplatin, and Alimta, pretty well tolerated, even to the point that most people don't lose their hair. And then, coupling that with Tagrisso, all of a sudden, we saw that was superior to Tagrisso alone in terms of outcome and duration of response, what have you. So I think in the right patient, it's a good option to combine chemo with Tagrisso.
Is the thought process around that the chemotherapy somehow like jump starts the targeted therapy, or is it just that I don't know how to explain it. I've always been curious as to, because sometimes it's like chemo first, then we'll put you on target, we'll give you X rounds of chemo, then we'll put you on targeted. Sometimes it's combination. Is there a general sort of understanding or thought process around why the chemotherapy, is it allowing the targeted therapy to work better, or are they just working better together?
I mean, I think, again, being a general medical oncologist and looking at other diseases, you do see this synergy between chemotherapy and targeted therapy in other arenas. Cancer cells are like kind of living organisms like bacteria. If you attack from this angle, a bacteria or a cancer cell can start to evolve mechanisms to defend this front. But if you attack with this chemo drug and targeted therapy at the same time, there's really no escape route for the cancer cells. So the synergy probably lies somewhere in that reasoning, that you're attacking from multiple mechanisms of action all at once. And there's no real way for the cancer cell to quickly build defenses when it's being attacked everywhere. So I think it's something like that.
So another question I have, and so I'm going absolutely off script right now, but I'm personally curious about it, and I think a lot of people probably are. So there are people out there who we fondly refer to as super responders, right? So I know one patient in particular, he was diagnosed, gosh, it has to be 18 years ago now, 15, 16, 17 years, I don't know, something like that, a long time. And he was on stage 4, EGFR positive. He's on Iressa. And then they shut down the trials here in the United States, but allowed him to continue on drug. And he has been on that drug for a decade and a half with still no evidence of disease. I know other people who have been on EGFR, and these are just, I hear about it more from people who are on EGFR TKIs. So I'm curious, like, do we know, or is there a hypothesis, I guess, around why some people just seem to just respond and respond and respond, whereas others maybe aren't quite as lucky?
Not one that I've bumped into.
Yeah.
I think, at some point it's just, we know what we don't know, and that is that, at the time a patient's diagnosed, let's say, depending on what other environmental factors they were exposed to in their life and genetic factors they were born with, germline mutations that Danielle alluded to earlier. Everyone's different at the time of diagnosis, so you can have tumor cells that are so ugly right off the bat and have so many mutations and have already developed the propensity to develop resistance to therapy quickly, versus other patients where those mechanisms really aren't in place and the treatment strikes so hard and fast at the core of the cancer cell that the remissions that are induced are durable in terms of decades, But I don't think, that's the key. That's the central,
are the people I want studied.
That's the key on a genetic basis. What is the difference between someone who gets IRESA, that was sort of the seminal, great-grandfather of EGFR treatment, that typically in terms of potency is felt to be orders of magnitude less potent than Tagrisso, let's say, and yet with the right patient, it hit the mark so perfectly that he's been in remission for, and probably that will continue indefinitely.
Yeah.
But who knows? It's certainly somewhere within the DNA, the answer is, but no one knows
I'm just
yet.
so curious about it because I've had the pleasure of meeting thousands of people now over the last almost 2 decades I've been doing this, and there are those people, and I can't help but think, man, I want to get them all in a room or in a, not in a lab. I don't want to put all you people in labs, but
in a test
something somewhere, because I think somewhere out there is a key to unlock this.
There's a commonality on a genetic level somewhere. But you bring up that miracle patient, because we're talking about EGFR mutations. It was back right as I sort of emerged from fellowship, so kind of in the early, mid to late 2000s, when this data with pancreatic cancer emerged that combined gemcitabine, a drug we use in lung cancer too, but a chemotherapy drug, kind of felt to be one of the few drugs that had any measurable response rate against pancreatic cancer cells. And then all of a sudden, it was in one clinical trial, they combined the gemcitabine with Tarceva, which we were using pretty much exclusively for lung cancer at the time. And the data in the trial as a whole wasn't that impressive. It sort of showed that the patients who received both drugs, there wasn't a lot more toxicity, and they did a little bit better in terms of overall survival, maybe a couple months, but it didn't take the world by storm. And yet, I have a patient, one of the first patients I met at El Camino, who came to see me and had disseminated metastatic pancreatic cancer. It's like there wasn't a place in her body the cancer wasn't. And so I said, man, the best we can do here is let's try the gemcitabine, but sometimes Tarceva works miraculously for lung cancer patients, and so gave her both drugs. And 8 weeks later, we did a scan, and about 95% of the disease had disappeared. And so, Fred Marcus was alive at the time, and was a great mentor of mine. And I said, Fred, can you see this? And he was like, well, it sure as hell isn't the gemcitabine doing that. And I said, yeah, exactly. So even in the field of treating pancreatic cancer, EGFR mutations have to be there. And that's certainly what has kept that patient in remission also. It's been about 18 years now. Metastatic pancreatic cancer, in complete remission, clear scans when she had disseminated disease to begin with, traveling the world. So speaks to your point. What was it in her that allowed that kind of response?
Yeah, and I want to jump into miracles like that and clinical trials and having healthcare providers who will think outside of the box, right? Because a lot of these patients, particularly late-stage patients with lung cancer and pancreatic cancer, to your previous story, are looking for these miracles, right?
Yeah, absolutely. It's interesting in the field of oncology. When you meet medical oncologists, I'm struck again and again by patients who come to see me where a patient will go to see a medical oncologist, sometimes even at very big academic centers, and the medical oncologist will just be sort of nihilistic and just, be very negative and just say, well, what do you want me to do? We can have little things that can sort of buy you some time, but, and I just never understood that. At an academic center in particular, those are the places where they should be bending the rules and thinking outside the box and say, hey, we have some interesting things going on. We're on the cutting edge of research, and let's have hope. So I think that's the key, though, to always understand that even though you may have advanced disease, that try not to panic, do the molecular profiling, turn your disease into diabetes, and let's see what we can do. I've found that when you take that approach and you're always positive, and as an oncologist, looking for the needle in the haystack, and not being afraid to bend the rules a little. I mean, to me, clinical trials are great but I would never let data think for me. I think that data is there to help guide decisions. But sometimes there are situations arise where you sort of have to, have the courage for your patients to take a leap of faith and say, well, if this works here in this trial, and this worked here in this trial, let's put them together and see what happens. I mean, honestly, some patients have disease that's so advanced or so aggressive, even if you're bending the rules, there's a huge upside. What does that patient have to lose? We know what's going to happen if we're not creative, so let's go for it.
It's such a treat to hear you talking like this, because I think you're absolutely correct. We talked a little bit about rural settings with no finger pointing at rural settings, but this kind of thing happens everywhere. Academic settings, major academic institutions, some that we all know about. And I think part of that is because, and this is no fault, maybe a little, to the healthcare the treating providers who tend to get busy in their days and sort of lose sight of why they're there to begin with, right? And so this is something that particularly the support services team, preaches at the tops of mountaintops, as often as we can. And that is, if you are in a situation where you are not feeling comfortable with your healthcare provider, you don't feel like you're being listened to by your healthcare provider, it is time to find a new healthcare provider. I think it's so, so, so important that the person diagnosed and their care partners or loved ones or whoever might be there with them are part of this conversation and the decision-making process. And it's people like you who make that type of a difference to the people that you're treating. And I think, when you said your sort of approach is, hey, let's look at this like diabetes. We're going to throw everything in the kitchen sink at this, and we're going to do the best we can. That creates a mindset in the individual diagnosed.
Exactly.
And it's from one person who hears that story versus could be the same guy who hears, this story from, well, I guess we can try this, but I'm not making any promises. The outcomes are so incredibly different for people who can keep positivity and hope and their head in the game while they're being treated.
Oh, absolutely. I mean, we can talk about molecular genetics and driver mutations and chemotherapy and targeted therapy for hours and days and months. But when it comes to treating cancer, there's also an intangible set of variables that occur. And I always tell patients, I have my part of the equation where I have to devise the right treatment plan for you, but you have your part of the equation too. I can't be working harder to save your life than you are. So here's your homework, and that is you need to drink water like it's going out of style. You need to stay hydrated. You need to eat. You need to maintain your caloric intake. And as 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 emotional as the diagnosis is, and every patient, every doctor goes through it with the patients. We all have our moments, and you can get discouraged, but to fight through that and to stay active, not just be pulled to the bed and the couch and the remote control, and fight for your life to get up and move, because when you get up and move, even if it's a 5-minute walk on the days you don't feel great, that minimizes side effects. It keeps your muscles strong. It keeps you alive, so that then when we need to maybe use a different therapy, if the cancer progresses, you're in that much better shape to do so. And I always tell patients, hey, to beat this, we need your mind and your spirit and your body all integrated and driving like a locomotive in the right direction, in the positive direction, so that we can get a leg up on this. And believe me, with all the driver mutations and all the therapies we have, I've watched patients over 25 years of doing this now. We're getting old, right? Warriors in the game together,
Yeah.
but we've been doing this a long time, and you will definitely find patients who will themselves to live and do well. And so your job as the oncologist, I think, is to also foster the intangibles as much as you're fostering the right tangible therapy program.
Yeah, I could not agree more. I wanted to kind of do this while you were talking, because that whole mind, body, spirit thing is such an important part of this. And there's not a patient that I've talked to over all of this time who I haven't said, that does not mean you aren't allowed bad days, because a cancer diagnosis is scary. You're allowed bad days. You just can't live in them. Yeah. You can't do it every day, right?
Exactly.
You have to get, and I remember this when my own mom was diagnosed, and there were days she would just be like, and I'd be like, okay. But then if that turned into 1 or 2 or 3 days, it was like, listen, lady, now you don't have a choice. Now you don't have a choice. Yeah. But it really does matter, and it really does make an impact. One of the things we haven't talked about, and I'm trying to be mindful of time, is treatment monitoring, because I've heard from patients also that varies. So what does it mean, A, and what does it look like?
Are we talking like patients with metastatic disease?
Sure.
Okay, well, we don't want to be asleep at the wheel as we're doing these treatments, such that the cancer is growing and progressing right under our nose. So I have to admit, I mean, I'm pretty aggressive with re-imaging patients. That's a big part of assessing response to treatment, redoing scans, and whether it's CT scans, PET scans, brain MRIs. I mean, a really loose rule of thumb would be to give treatment time to work and reasonably and accurately assess response to treatment X or Y. You usually have to be on that therapy for at least 2 months. And so re-imaging, rescanning a patient after 2 months is important. That's one facet of treatment monitoring and surveillance. Then another facet is sometimes you have really routine blood tests called tumor markers that can be elevated. The best example in lung cancer, and again, all oncologists have different styles. Some like checking the tumor markers, some don't. I do. The marker is CEA, and it's often quite elevated with adenocarcinoma of the lung in particular. I think it's another piece of information. It's another piece of information to use. Sometimes, if the scans are clear but the CEA is rising, that can be an early sign that a patient's cancer cells are developing early stages of resistance to whatever you're doing. And it can make you want to scan them more often, let's say, or see them more often in the office. So I like checking those routine tumor markers, but surveillance and assays looking for MRD, right, minimal residual disease, are also becoming very popular. For example, the Signatera test or Natera test is an assay looking for circulating tumor cell DNA in the bloodstream. It's a very interesting test, I have to say. It's actually a patient who brought it to my attention for the first time, and I started to research it and say, okay, this is kind of interesting. And again, listening to your patient. doctor, can we send this? Sure, what the hell do I care? I just have to sign a piece of paper. So let's see what it shows, you know. And if you have to, of course, have the right mindset and make sure your patient does too, that this is not the be-all, end-all. This is a piece of information. We may not really know what to do with it.
But the more pieces you can get.
Exactly.
Yeah.
And so, but what's interesting about Natera is they start to send it, they actually create a personalized probe based on a patient's solid tumor biopsy. So what that test is looking for is the patient's own tumor cells with their own DNA signature. So, I mean, it's like the CEA test, but 1,000 times more sensitive. So
I know some people in this room who are part of that and might have family members that work there. Not that anybody has to comment on it, but I know people who have used this type of testing and are benefiting.
Well, absolutely.
Yeah.
Again, I mean, it's like if the CEA is going, if you wait for a scan to detect when the treatment isn't working, and that's over here, and then you use the CEA, and maybe you get a hint that things aren't working here. With the Natera test, you may get a sense that things aren't working here. And so I think it's a valuable piece of information. It can allow an oncologist to intervene earlier to change therapy if they need to, rather than, again, not be watching the patient at a short enough interval, and then you get one scan that's clear, the next time you scan them, it's like jailbreak, and the cancer has kind of exploded. You want to avoid that situation, because then you're scrambling to put a therapy plan together, get insurance authorization, get everything moving. And oftentimes, if you do that sort of thing, and there's a jailbreak, as I call it, with my patients, they're sicker too, and they're getting sicker rapidly. And so everyone's just going crazy and panicking. So I think these tests have a really important role to kind of intervene sooner before the jailbreak occurs.
You keep talking about these tools, and it's just giving me like flashbacks to some of the earlier days of this very meeting where Bonnie, my mom, I'm not saying that because you guys don't know who I'm talking about. I'm saying it for anybody who might be watching that doesn't know Bonnie or that she's my mom. She used to always talk about the tools in the toolbox, right?
Yeah.
And like carpenters don't go build houses without all the tools they need to build that house. And healthcare providers and medical oncologists and really the whole cancer care team shouldn't be making decisions without bringing all of the tools to the table. And I think that is a perfect example.
It is. It is. I mean, you should be using all your tools. I mean, again, it's not, sometimes oncologists have an interesting take on things or try to presume they know something about a test, or they just have some sort of internal bias against it. Or some oncologists, you know, we're all different people, and some oncologists are more conservative, let's say, or more cautious, and they don't want to embrace new technology until it's certain, based on a series of 5 randomized, double-blind, placebo-controlled trials that works and it means something. And until then, it's garbage.
Yeah.
I, on the other hand, I mean, I've always felt that it was actually my wife who said, you know, after playing a game of Monopoly and almost getting divorced over it, she said, you know, I've realized something. You are pathologically competitive. And I said, you know, yes. I mean, I mentioned basketball earlier. When I was playing basketball, to beat me on a basketball court, it really did have to be over my smoking dead body, because I would do anything, including, you know, grabbing shirts, grabbing shorts, yanking shorts down, hitting people when the refs weren't looking, anything I could do to get an advantage. So my wife said, you know, I figured this out. You're so competitive that in your job you compete with the cancer. And I said, that's right. And I think that, to me, that's why when I see a patient, I'm never panicked. I tell them, you know, do I look worried? Do I look panicked? I'm not panicking, because all this is a complex DNA-driven chess match with cancer cells that think they can beat us, you and me, you know, my patient. And I try to tell them that's not going to be the case. And so to win a game, you need all of the tools on the table. I tell them if the cancer makes a move, we make a counter move. And that's how, and we're going to make counter moves until we get in front of the cancer and we are on offense dictating the tempo to the cancer and the cancer's reacting to us. So that's how I like to practice oncology.
Yes, everybody wants to clap, yeah. I'm like, it would bring tears to my eyes. Like, everyone should have a healthcare provider who sees the cancer in any person diagnosed, and I don't care what kind of cancer it is, as competition, and should be striving to beat it. It's just such an incredible way, really, to kind of bring this conversation full circle. What I want to ask now, sort of in closing, is what do you most hope people take away from this conversation, or even something that we may not have touched on? What do you most want people to take away?
I would most want people to take away that kind of the first comment I said, that it's so easy to get overwhelmed when you're diagnosed with cancer, especially a cancer that's advanced, that to always know that, and to encourage friends or family members who are diagnosed or find themselves in the same situation, that, you know, really do look for a team that's going to kind of diffuse the situation and say, this is the plan, this is how we're going to attack. A team that is going to bring all of the tools on the table, many of which we talked about tonight. How can you fight the battle without knowing all the weapons in your arsenal? And to just have patients take away that, you know, there's always hope, and to really find a team and an oncologist that fights for you, competes with the cancer, and will most importantly, like, not be confined to standard ways of thinking, if it benefits you by blending this trial and that trial and different philosophies, bring them all together for the benefit of the patient, that, you know, there's always hope, and keep searching for it. Retest with molecular profiling, constantly looking for the needle in the haystack that can help you beat the disease. So that's what I want. Another exciting field we didn't touch on is actually AI. Again, speaking of rabbit holes, but I mean, but that's a really exciting field that has many applications for oncology, both in terms of diagnosis and treatment and sequencing of treatments, and, you know, how that will. I think another take home would be, you know, look back 15 years at where we were, and now look at the array of targeted therapies we have. Well, let's look ahead 15 years. I mean, that's what I want people to take home too, that this is an exciting field, changing on almost a daily basis. And, you know, there may be a point where stage 4 non-small cell lung cancer truly becomes like high blood pressure and chronic can disease. Just be, you know.
Yeah. I love that. I too am really excited about AI, artificial intelligence, and its impact on the healthcare, on healthcare, like in general, positive impact. I mean, and I think we are only at the very early stages of how this is going to explode in this arena. So I think yes, and like, pick a topic, any topic. There's a lot of, to your point, really exciting things happening in cancer care right now. Not that cancer is exciting or a diagnosis is exciting by any stretch of the imagination, but
the idea that we are increasing the number of weapons that we use to defeat lung cancer is exciting.
Agreed.
Right?
Agreed. Thank you.
You're welcome.
Thanks for coming
and talking with us today. Well, it's my honor to speak to everyone.
Yeah, absolutely.
Yeah, my pleasure.
Absolutely. We do have a new text reminder platform that is working splendidly for those who have already signed up for it. And it's just a way for you not to have to rely on checking your email to remember when these meetings might pop up. And Michelle gets all of the responses to those texts And the phone number is 844-871-7558. It should be popping up on the screen for those of you watching from home. And all you have to do is text the word living room to that phone number, and it will automatically sign you up. If you decide you hate it, you just text stop when you get something, and you will never receive another text message from us. I will say that those that use it are finding it very helpful and useful. And then again, a huge thank you to Dr. Shane Dormady for coming out and speaking with us today. All of you watching live, those of you who will come back and watch post live, Onyx and Ash, Penn Media, who comes here every month, hours before any of you get here to get all of this set up and tape everything down so nobody trips and hurts themselves. Thank you all so much for what you do. Michelle Zay, who I've mentioned a couple of times tonight, for really being the sort of invisible woman for those of you who aren't in this room, behind the scenes ensuring that this goes off without a hitch every single month. A huge thank you to her, the entire GoTo team, just for everything you do. And then I would be remiss in not thanking our supporters, because without their support, we would not have the funding to bring this ever popular and so important programming to you all. So Amgen, AstraZeneca, Bayer, Boehringer Ingelheim, Bristol Myers Squibb, Daiichi Sankyo, Eisai, Foundation Medicine, Genentech, Johnson & Johnson, Merck, Mirati Therapeutics, Novartis, Novocure, Regeneron, Sanofi, and Takeda Oncology. Thank you all for your support. Thanks, everybody, and we'll see you next month.
So I'll be brave if you're brave. I'll be brave, but only if you're